trend in the development of engineering is towards a rational exploitation of materials and improving the economic parameters of production. This includes economical methods of processing steels and other technological materials. The word technology means the application of scientific knowledge for practical purposes. However, we will use it to refer to the science of technical principles of the manufacturing process. The metal forming and welding technologies have a significant share in the global production of machine components and joining elements made of metals and their alloys. These technologies meet the requirements for very precise machine and instrument components for air, road and other transport, for military purposes, power engineering and also for consumer goods. Components produced by metal forming satisfy even the most demanding technical criteria and demands made on mechanical properties. In order to manufacture such components, it is necessary to work out the manufacturing process and simultaneously to ensure the design solution of the tool for a given machine, the manufacture of special tools and their testing, the assembly and adjustment of the machine, the preparation and inspection of input material, inclusive of the required heat treatment and surface treatment or finish, the manufacture of the required number of components. A technological project for the whole range of operations needs to be elaborated, including, among other things, an evaluation of technological and economic advantageousness. At a certain stage of bachelor and master degree studies specializing in engineering technology, the students apply their acquired knowledge and write a technical report in the form of so-called end-of-year, specialized and final projects, which precede the bachelor degree projects and master degree diploma projects. The basic aim is to work out independently a semester project on a given technological topic. The topics are oriented towards proposing manufacturing technologies based on metal forming, welding and possibly also surface treatment. Concurrently, the students also solve problems concerning tool design, application of production machines and equipment, quality and metrology. Under the technical and methodological guidance of their teachers, the students acquire basic experience of and skills in working out technical reports and drawing documentation in accordance with current technical standards and rules.
Using this procedure, we obtain the same result shape, but this procedure is accompanied by changes in metal properties. This is to say that with a lower number of operations, we needn't always obtain the required mechanical properties, as with a higher number of operations, when their setup and the choice of suitable blank eventually result in a technology that, from the viewpoint of plastic deformation, has in all parts balanced roughly identical values of hardening.
What does such a project contain? Assignment and drawing of the component. Complete literary reference with abstract. Introduction. A discussion of the respective technology based on the literature studied. Evaluation of the current state of solution. Design of own production technology. Design of the required machine and equipment. Design of the tool. Technical and economic evaluation. Conclusions and recommendations. Let us now demonstrate with an example of a specialized or an end-of-year project which the student has to do in order to assemble the necessary data and work out the project. After being given the assignment, the student gets acquainted with its content and thinks over the first steps. At this stage, the student draws on the knowledge and experience gained in preceding studies and finds out what further information they will still have to complement by studying or consulting. The aim of the literature search is to obtain the necessary data from books, journals and manufacturers' publications that have something to say about the problems concerning the project assignment. The student goes to the technical and scientific libraries of the department and the faculty, looks up and borrows the respective literature. This is the time of searching for and absorbing the necessary data in books and journals, or in the proceedings of technical and scientific conferences. Today, much information is available on the internet. Via explorers, the student finds the literature giving fundamental information on solving technology problems of manufacturing the assigned component, on the design of tools, and on the machines and equipment necessary for production. In the conclusion of the literature search, the student, using an appropriate text editor, prepares a list of references in compliance with the CSN ISO 690 standards. In the form of a literary study of about 30 pages, the student presents the information obtained in literature searches concerning the technologies, materials, tools and machines that relate to the project assignment. This is a technical compilation in which the student should avoid taking over redundant information and mere copying, with the exception of quoting important statements. The sources used and the figures taken over must be listed in the references. On the basis of all the information obtained by literature searches, and on the basis of the above literary study, the student evaluates in a separate chapter the current state in the production of components that are usually of similar shape. Now, the student gets down to designing their own production technology, starting usually from the evaluation of partial technically acceptable variants of the manufacturing process. The selection of an optimum variant is based on satisfying the technical and economic demands made on the assigned component. For the selected optimum variant, the student provides the necessary technological calculations. The result of the design of production technology is the technological process of the production of assigned component given by individual operations with detailed dimensions. A suitable production machine must exert, with sufficient reserve, the required deformation force and perform the required deformation work. It must also allow the composing of a design solution for the special tool and have the required capacity expressed in pieces per unit of time. The proposed design arrangement of forming tools for individual operations of the forming process must be in keeping with the design setup of the machine. It is a matter of composing upsetting punches and extrusion punches in the punch block of the heading slide of the forming machine, and upsetting dies and extrusion dies in the die block of the forming machine. Experience obtained in earlier technologies is combined here with the application of standard design solutions, which must meet the requirements of technical acceptability and operational reliability. In the tool design, various versions of computer support, like AutoCAD, can be made use of. After completing and checking the tool assembly, it is printed out on large area plotters in sizes of up to 123 by 88 centimeters. The tool assembly represents a certain culmination of elaborating the project. As it documents the manufacturing process in its individual operations, its visual inspection is indispensable. The next step consists of providing the working drawings of individual tools and prescribing the required heat treatment, surface treatment and strength. An important part of the project is the assessment of technical acceptability of the solution and its economic advantageousness. Here the proposed variants are judged and compared with other technically acceptable technologies such as casting technology and the technology of machining from solid blanks. In the concluding chapter, it is necessary to sum up briefly but clearly the content of the assignment, the manner of proceeding with the solution, with emphasis on the main steps and the methods used in the approach, the results obtained. The conclusions are usually complemented with authors' recommendations regarding further possible approaches in the course of detailed solution. After the conclusions, a bibliographic entry is written, which in addition to a complete literary reference to the elaborated project contains approximately 10 to 15 lines of concise and specific roundup of the conclusions. The composition and formal layout of the project depend on the possibilities available to the author, i.e. the student. What must never be neglected is the formatting of text, sequencing of figures, listing of the symbols used, and a complete list of the literature used. In classes of, for example, the Specialized Project course, fourth-year students of master degree studies defend their projects before the whole study group in the presence of teachers. In this way they test their ability to defend their projects and convince their audience of the advantageousness of their solution. Both the content and defense of the project are an integral part of the final evaluation.